In the previous video, we saw how to use the Pythagorean theorem to solve a right triangle. If we know two of the sides of the right triangle, then we can use the theorem to find the third side. So this is very good if we happen to know two sides of a right triangle, but if we only know one side, then the theorem really doesn't help. But this is exactly where trigonometry comes in. In trigonometry, if we know one side and we know an acute angle, then we can solve the triangle. Okay, so first of all, we need to get some definitions. And we'll work with our standard typical triangle, ABC, with the right angle at vertex C. And the lowercase letters A, B, and C will represent the corresponding opposite sides. And we're going to let this symbol here, which is the Greek letter theta, represent the measure of angle A. And this symbol here is sometimes used to represent the measure of angle B. That's the Greek letter phi. Okay, so here's the diagram again. And just to remind you then, the measure of angle A we're going to call theta, and the measure of angle B we're going to call phi. Okay, so now the definition of the sine ratio. The sine ratio is defined to be the ratio of the opposite side to the hypotenuse. Okay, and we can abbreviate the sine ratio with SIN. This is universally done. So for example, if we want the sine of angle theta, which you remember is the measure of angle A, then we can calculate that by dividing side A, which is the side opposite angle A, by the hypotenuse C. So A divided by C will give us the sine ratio for angle theta. And for the other angle, the other acute angle, phi, which is the measure of angle B, then the side opposite is B, little b, and the hypotenuse, of course, is still C. So, for example, we saw earlier that a triangle with legs 3 and 4 has hypotenuse 5, and so we know all three sides, and we can compute sine ratios. Let's get our diagram again. Okay, so here's angle A, angle B, and angle C, which is the right angle. And the measure of angle A is theta. Measure of angle B is phi. And here's side A, side B, and side C. And we saw that the sine ratio is defined to be the ratio of the side opposite to the hypotenuse. So for theta, we have A over C. In this case, we're given A is 3 and C is 5, so the answer is 3/5. That's all there is to that. And then sine phi is the ratio of the side opposite. In this case is B, little b. And B is 4, so we have 4/5. And that's all there is to that. All right, next ratio is the cosine ratio. And this ratio is defined to be the ratio of the adjacent side to the hypotenuse. And cosine is abbreviated COS. In our example triangle, we have cosine theta equals B over C. Okay, so remember, cosine is the adjacent divided by the hypotenuse. So the side adjacent to angle theta is B, and then divided by the hypotenuse. So B over C, and cosine of phi, adjacent side, so A over C. Okay, let's do another example now. We have A equal to 5, and B is equal to 12, and C is equal to 13. Find the cosine of theta. Okay, so we're letting theta represent the measure of angle A. And phi representing the measure of angle B. Okay, so we're doing the cosine now. So cosine of theta is the side adjacent to angle theta, so that's B divided by C. And in this particular case, 12/13. Cosine of phi. In this case, we have the side adjacent to angle phi is A, so this is A over C. The answer is 5 over 13. Okay, one more trig ratio. The tangent ratio is defined to be the ratio of the opposite side to the adjacent. In the other two ratios, the hypotenuse was involved, but not in the tangent ratio. Tangent is abbreviated TAN. And in our example triangle, we have tangent theta is A over B. Okay, so in this diagram here, theta, measure of angle A, side opposite is little a, side adjacent is B, so we have tangent of theta is A over B. And the tangent of phi is the reciprocal, B over A. Okay, so for example, going back to our 3, 4, 5 right triangle, if A is 3 and B is 4, so we'll say now A is 3, B is 4, then tangent of theta is 3/4. And the tangent of phi is the reciprocal 4/3.